Without a conscious thought, we move our arms and hands. Our brains are controlling the movements, telling the arm where to go, the hand what to do. When we develop robots, we want them to mimic the same motions, but short of having a brain, how can they do that? Researchers rely on kinematics, or how things move, to engineer the motions of a robot. And a small firm in Massachusetts has been working with NASA to provide kinematic solutions. In 2001, Energid Technologies received Small Business Innovation Research, or SBIR, funding from the Johnson Space Center to develop software to control NASA's robots, such as Robonaut.
They wanted a control software for kinematically redundant bifurcating manipulators, or branching manipulators, something that might have fingers, for instance. And it needed to work very quickly.
While working with NASA, Energid developed a product they call Actin, a control and simulation software for robots with up to 100 joints.
And that's really the challenge that Actin is solving. How to optimally place your hand or your end effector or your multiple hands in a way that's going to be efficient and is going to avoid collisions, is going to, for instance, optimize for strength.
During that time, they also developed part of another product, Actin, a machine vision software to help robots with perception.
You can train on specific CAD models of objects that you would like to identify, and it will identify those objects and it will also localize them, meaning that it will tell you the position and orientation. And it does that from standard color cameras.
Actin fed into another NASA SBIR project, this time with the Jet Propulsion Laboratory on a robot for lunar and Mars missions. Energid added dynamic simulation capability to the software, allowing NASA robotic designers to quickly test models in different scenarios. Actin and Actin provide solutions for other federal customers as well. The Army has been developing a robot that can find and retrieve wounded soldiers called the Battlefield Extraction Assist Robot, or BEAR.
We did a lot of work in simulating that process, simulating the process of finding a soldier and picking up the soldier with the robot. And part of that also was controlling it.
On another project for the Army, Energid is developing an intubation or breathing system. With Actin controlling the system, it allows for easier insertion of the tube into the human throat. For the Department of Agriculture, Actin is being integrated into a system for harvesting citrus crops. By changing the design models from a soldier to a grapefruit or an orange, a robotic frog tongue can effectively identify the fruit to be picked, making the whole process easier and faster. SBIR, a Norwegian oil drilling firm, contacted Energid for a solution too.
They had heard about the work that we'd done for NASA, and they needed control software for a new underwater autonomous oil rig that can control all the mechanisms on the rig and could also avoid collisions.
And as NASA prepares to explore other planetary surfaces, Energid is teaming with NASA's Ames Research Center. Through an SBIR contract, the firm is using Actin to develop a simulation capability for K-10 robots. Robots that will one day mimic what we do.